It's math time with Heinz. It's math time with Heinz. Math time.
All right, folks, let's jump into lesson 5 here, where we're going to practice solving systems of linear equations. So we have our three methods. We have our three methods of graphing, substitution, and my favorite, elimination. So those are our three ways that we can solve a system of equations. We can graph the two lines, we can use substitution, or we can use elimination. And today we're just going to practice doing a couple problems using all three of those techniques. So Franco and Carol, who spelt weird, went to a bakery to buy desserts. Franco bought 3 packages of cupcakes and 2 packages of brownies for $19. So I've got a Franco equation here. 3 packages of cupcakes and 2 packages of brownies cost $19. Carol, whatever the heck his name is, bought 2 packages of cupcakes and 4 packages of brownies for $24. So X is the price of cupcakes and Y is the price of brownies. So let's go through Franco here. Franco said 3 cupcakes that cost X each and 2 brownies that cost Y each should give me $19. Notice I have to use X and Y because those are the given variables. The other equation comes from 2 cupcakes times their cost, plus 4 brownies times their cost gives me 24. So here's a system of equations that describes the given information. And they want us to solve this system by graphing. So unfortunately, we've got a lot of work to do here to graph this. This is a good graphing equation review. So when we graph, we need things to be y equals. So I've got to move that x term to the other side. So I move that negative 3x plus 19. And then I've got to divide everyone by 2. I like when my slope, there's my slope right there, is a fraction. 19 over 2 is 9.5, so I'm going to leave that as that. So here we go. I'm starting out at 9.5. That's my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9 and a half. And then my slope is telling me to go down 3 right 2. But remember, we're in the middle. So 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. That's kind of all we get there. So I'm going to draw in this line with my nice ruler. As best as I can, zoom. And I'm going to label that 3x plus 2y equals 19. And I'm going to wipe the sweat off my forehead because I've got to do it all over again. 2x plus 4y equals 24. So let's get y by itself again. Move the x term over. And then divide everybody by 4. 2/4 is 1/2 plus 6. So again, this tells me start at 6. 1, 2, 3, 4, 5. Start at 6. And then I have a slope of down 1, right 2. 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 So this line looks something like that. This is Carol's line, whatever her name is. And I'm going to label it 2x plus 4y equals 24. So we did all that work to find out nothing. That is my solution. That right there, that point that I have no idea what that point actually is, that is my solution to the system. So we did all that beautiful work to not find the answers. So we need to determine the exact cost of 1 package of cupcakes. So how do I find this? Well, if I saw this system and this graph paper wasn't here, I would use elimination. So let's just do elimination because that makes sense other than dealing with fractions and substitute. No, Keep it simple. Keep it simple. I've got a 4, so I want a -4 up here, which means I got a multiplier of -2. So times -2, times -2, times -2, which makes 0. This is so much nicer than dealing with that nonsense. And divide by -4, and I get x equals 3.5. And since it's money, I'm going to go 350, which makes sense. X is which? X is the cupcakes. The cupcakes, the package cost $3.50, which 1, 2, 3. This is about right there. $3.50 is about where that point of intersection is. Well, I'm not done yet. I've got to plug back in. So I'm going to plug back into the bottom one because I can do that in my head. I can do 2 times 3.5 in my head. It's 7. So 4y equals 17. So I get 4.25, which let's see if that makes sense. 1, 2, 3, a little bit more than 4. It does. So, and it makes sense because that's how much a package of brownies would cost. So notice that solving by graphing is really a terrible way most of the time. Unless you're using your graphing calculator and can see the solution, that's what we've got. That is what we've got here. I hope they enjoyed their cupcakes and brownies and saved me one. All right, a theater charge is not. We've done something like this before. The theater charge is $9 for an adult ticket, $6 for a kid ticket, 144 tickets. That's a different color because that's not money. There's their total money. So write a system of equations and solve. So this is one of them ones where I have to deal with money, which of course isn't green. Of course I use green for something else. I've got to deal with money. So $9 per adult, $6 a kid gives me all that money. This is my money equation, and now I've got to deal with my one dealing with the total tickets. The adults and children together have to sell me 144 tickets. Again, that's not money. This is how many people showed up. So I got one dealing with money and one dealing with the total. So I will use a little elimination here to solve this. I didn't touch the top, but I did multiply the bottom by -6. Why -6? I'd use -6 so that I could have opposites. I'm reaching for my calculator here so I don't make any embarrassing mistakes like I have previously. And of course the batteries are low. There we go, -864. 3a equals, so I'm going to use my calculator again here, even though I can do that in my head, 300. So that means there's 100 adults. Well, we're not done yet because we need adults and children. So common sense, don't plug into the crazy one, plug into the nice one. Adults and children must be 144. Well, I used up 100 of them. So children has to be 44. Only 44 kids at this movie and 100 adults. We've got one more problem and we're done for the day, folks. A line passes through the point 37 is shown. That is a true statement. Write the equation of this line. So I need to write the equation y equals mx plus b. Well, I know my b, my y-intercept is 1. But I need my slope, my rate of change, so I draw in one of those triangles. I draw in a slope triangle up to right 1. So my slope is vertical over horizontal, up to right 1. So the equation of that line there is y equals mx 2x plus 1. That's the equation of that line. Determine if the equation you wrote above and the equation form a system with 3, 7 as the solution. So let's see. I know 3, 7 works for this guy. It doesn't work for this guy. 3 plus, so x plus 3y, does it equal 24? Does 3 plus 21 equal 24? It does. So the answer is yes. 3, 7 makes both true. How do I know it makes both true? Well, I plugged it into that one, and this one's on the graph, which means it's true. So we're good to go there. The equation you wrote above and the equation above form a system. So y equals 2x plus 1 and x plus 3y equal 24 form a system. Let's solve this algebraically, and because y is all alone, oh, he's so alone there, I'm going to use substitution. I'm going to do a little substitution here. Wherever I see a y, I'm replacing it with 2x plus 1. So x plus 3y equals 24. And I have to solve this equation. A little distribution action there. Gotta love it. 7x, right? 1x and 6x is 7x plus 3 equals 24. 7x equals 21, so x equals 3. But we're not done yet, because when we solve a system, I need x and y. So I've got to plug it in. Y equals 2 times x plus 1. X is 3. Y is 7, which we already stinking knew because we did it up there. But I just wanted us to practice substitution. All right, folks. So hopefully you're good with graphing, hopefully you're good with elimination, and hopefully you're good with substitution, because that's what we practiced and learned all week. See ya in the next video or in person.